So we're here in Cabo San Lucas. This is Dave Hardy, one of our crew members helping us take Bodacious IV back up to San Diego. Dave's an engineer by trade. He works on, I know, solar panels and stuff, but all kinds of engineering.
Also in manufacturing and making various things.
Okay. So Dave's going to help explain what keeps the mast up here, Dave.
Well, when you're on a sailboat, a lot of the forces can be very complicated because the wind is blowing against the sail. You're trying to blow this tall mast over to one side. So to keep the mast upright, there's shrouds that come out from the top that you can see right now, and they come off to either side, and then down each side. And then each of the spreaders hold the shrouds out so that it forms triangles as it comes down, and that creates a wider surface for the shrouds to basically grab a hold of the mast.
Okay, so it's like an A-frame type thing, and so
it is indeed.
The further you spread the loads out, the better.
The more stable it becomes.
Because of the angle?
Mm-hmm. Because of the angle, and the farther out it is, it increases what they call the rotational moment of inertia, which is an engineering term.
Complicated.
Very complicated, and you calculate it through some relatively complex math. That in combination with some trigonometry, but it's all very doable, and it's a science that sailors and artists and mathematicians have worked out.
So if you're real young, say in second or third grade, and you're just learning basic math, you have to learn that to get to the level that gets to the next level, that gets to the trigonometry that helps you figure out these
start with addition,
loads.
subtraction, multiplication, division, and then it gets into more complicated trigonometry, and sine and cosine, and all that stuff is very, very important, and it boils down to some very simple action and reaction on a sailboat.
So that's cool. So I know on this boat, these shrouds are carbon fiber. How much load is on those, do you think?
Oh my word, I wouldn't even hazard that. I think the hazard is probably 2,000 or 3,000 pounds.
A few thousand pounds.
Mm-hmm. Several thousand pounds.
Like on the older boats.
And the outer ones,
yeah.
probably 16,000 pounds.
Yeah, 16,000 pounds. That's 8 tons of pressure on that. That helps create a tensioned system here that stays up.
Mm-hmm.
Now the
So
mast is all carbon fiber too, which is like a cloth of carbon, and it's embedded in epoxy.
A plastic sort of.
And so it's essentially
material.
a plastic composite mast.
Plastic composite mast.
Fascinating.
Indeed.
Well, let's take a quick look down below at the keel and show them how big the keel bolts are that hold the keel up.
And the keel is what, Dave? We both know how this works, but
well,
the sails are, the wind is pushing against the sail up on the top, and then what keeps the boat
down
from
in the
tipping
water,
over?
there's a big long keel that has a big bulb on the bottom that keeps the boat from tipping over, and that keel flows through the water, and that helps to keep what would be the opposing force, of the sails.
It becomes the riding moment,
okay,
and then keeps the boat from sliding sideways.
Okay,
Cool.
Stop it.